Yes, MIDAS nGen, which is a next generation solution for building analysis and design, can perform all these tasks together, like analysis, design, drafting, all in one single software solution. As you can see, there are many software solutions that you are using. Like when it comes to analysis, you use some softwares like STAD, ETABS or something, and even Gen. And further, when it comes to designing, you shift to Excel sheets. You have your homemade Excel sheets and all, in-house Excel sheets. And then there is drafting tools separately like AutoCAD and ZapCAD and so on. So the draftsman have to start from the beginning and create the entire drawing. So all these three software solutions can be combined into one single software solution, that is MIDAS nGen. Have you ever thought that CAD programs such as AutoCAD or Tekla, which draws drawings or shapes and CAE products like Robot and SIA or Gen, all these together, or have you even thought of modeling and interpreting whatever you do in CAD in a CAE software solution? Can you also imagine how good it could be if you could actually make a structural drawing right from the analytical model that you have made? The thoughts that you have with me right now are the questions of how to connect the relationship between CAD and a CAE software solution. MIDAS nGen solves both geometric and analytical models in one single program, and we refer to this modeling concept as bi-modeling, when an analysis model is created automatically by modeling 3D shapes. It is also called as a CAED platform because it integrates CAD and CAE. Now only the geometric modeling is done, and the analytical model is created in the program. Now you don't have to think about the difficult concept of finite element, mesh or node, which is the concept used in analytical models. You can see you're now free from the mesh. The most important concept of MIDAS nGen is drawing to drawing. From architectural drawings to structural drawings, all in one design system. Integration, wherein all business processes can be integrated into one using MIDAS nGen. Then there is automation, which reduces production time significantly. There is optimization that can enhance the optimized quantity takeoff. And with the high quality of design deliverables, we can generate the reports very easily. Now let me take you ahead to its application areas. Being an automated and optimized process, from modeling to report generation, it provides a multidisciplinary and fully integrated solution for structural designers. So as a structural designer, you can go ahead and use MIDAS nGen for apartment buildings. It could be single-storied structure, 3 to 4-storied structure, or as you can see here, you can have concrete frame with steel roof. We will be seeing a demonstration on such kind of a structure. A car park building, Then you can have multi-towered structure as well, and you can also perform analysis and design of shell. When it comes to complex facilities, you can use MIDAS nGen very efficiently. So we can see over here how the beams are having plates at the top or as well as in the center part of the beam is itself, slabs at the top and the center part of the beam. And we can easily perform the analysis. No need to worry, all the connections and the translation of loads will be taken care of by the program. When it comes to irregular structures, you can easily do the modeling and you can get the analysis results. In former buildings, curved surface shape analysis can also be performed very efficiently by MIDAS nGen. All this mesh that you can see over here are automatically generated by the program, so you need not worry about it at all. Multi-towered structures, well, we can have two separate diaphragms in a single model. So it becomes easier for us to take out the results of both the towers simultaneously. It's not just RC structures, but also steel structures in MIDAS nGen, which can be used. There is another example or application of a refinery frame. We can see over here how easily the drawing data was automatically generated. If you are anywhere interested into water tanks or silos, then you can definitely go ahead and make use of MIDAS nGen. Ball tanks. We have got really good wizards in MIDAS nGen that can easily create such kind of complicated structures. So tanks with large foundations can also be analyzed and designed. When it comes to a shell member analysis like a cooling tower, go ahead, download MIDAS nGen. And you can also use for steel members and pylon towers. So I've shown you right now all these applications. Now let's see how to do it in MIDAS nGen. Let's see a demonstration and get a feeling of how impressive or how mind-blowing you can get into MIDAS nGen. How you can get a mind-blowing experience into MIDAS nGen. So I'll open MIDAS nGen now. This is a structure we are going to be creating. So I'll open up a new file. One good thing about MIDAS nGen is that we can run as many models in one single window. So there are many models open up in this single window, so you can go to each model at the same time. Let me first introduce you to the user interface of MIDAS nGen. In MIDAS nGen, we have ribbon menu at the top, and we have got some tree menus over here on the left side, and we have properties menu as well. At the bottom, there is a message window. If there are any errors or warnings, you can just take a look at it very easily. Then further, we have unit system over here. Can just change it to kilonewton meter. And there are some easy shortcuts available over here, similar to AutoCAD, like auto intersect, then orthogonal, and you can have snapping control as well. You can go to any view from this box right over here. Again, it would remind you of AutoCAD. And there are three methods or three modeling modes in MIDAS. One is in 3D mode, plane mode, and story mode, so that we can have really fast modeling and very clear clarity in the modeling procedure. Alright, so without any further delay, let me begin with the modeling. So here we have an option of tracing architectural drawing. So let me firstly take you to the architectural drawing. Alright, so here we have our architectural drawing. So this drawing, as you can see over here, of this structure, which is made up of steel as well as RC. So out of this, we have the locations of the columns and the footings, and the beam layout plan as well. And we have locations of slabs, and towards the central portion we have got a truss. Alright, so these drawings are already there with you. This is from where you all usually start. Now instead of like going to this analytical software solution and starting from scratch with the location of columns and then sizing and so on, we are going to be directly tracing the files. So I will be just importing any DWG, or I mean you can have DWG or DXF file. So let me open up the foundation, foundation 1, one plinth beam file, one trace beam file, and open it. Now these files that we have are in mm, and I have my unit system in meters, so the scale factor is 0.001, which is the default, but we need to always take care that the unit that we are using in the CAD file and nGen is the same. So after that, I can click on OK. Alright, so we are done with importing the tracing file. Next, we can also do the importing of a DWG or DXF file. This can help us import the entire member, or you can also import only the sketch or just the drawing of your members. Like over here, I can use truss, or I can use over here the foundation. So I'll open that. In this, we have the choice of selecting the layers. So I'm selecting this column layer. As you can see over here, we can get a preview as well. And after that, I'll just click on OK. So this, whatever we can see right over here, is the outline of the foundation, and it is just a sketch, not a member yet. Okay, so you need not worry at all. After we are done with the importings, we will go ahead with the story definition. MIDAS nGen has automatic lateral load application, so we can simply define the stories, and I'll have two numbers of stories. Okay, one story is of 1.2. This one is going to be from foundation to plinth level, and then I'll modify the height 4.825, and that's it. So from here, from this table itself, we can modify the height, and once you make changes over here, those will be also reflected dynamically in the model. So no need to move any of your elements or nodes. Alright, so the story definition is here, done, and next thing is the CAD drawing. The file that we just imported for tracing is to be provided to the stories. So here on the foundation level, I'll have the foundation, and for the plinth level, I'll have the plinth beams. And since for quick modeling, I'm going to be using plinth beams for my roof level as well. So this is done, and then I can simply click on OK. And here we go, we have got our architectural drawings, or our structural drawings in front of us, ready to be used. Alright, next thing is define. We can go from left to right in MIDAS nGen and finish with our entire modeling so that we don't miss anything. So next tab is the definition tab. In MIDAS nGen, we have a model tree menu. Okay, so in this model tree menu, you can see all the information like the story definitions. Then you can see over here the properties defined. There are some predefined material properties. These are as per Eurocode, and we will be demonstrating today on Eurocode as well. However, there are options of choosing American as well as British standards. So I suppose you've been using British standards as well, so you can freely use the same. So there are some material properties and section properties that have been predefined, even the thickness. If we would like to do the modification, we can simply right click and we can go ahead to modify. Alright, so let's add, and let's see how to add section properties. So this is also a very good function in MIDAS nGen. All you need to do is click on add, and in MIDAS nGen itself you get a location where you can sketch your own shape. So here, instead of like just solid round, I can insert a template of solid round, and then I can do the sketching of my irregular shape. For example, I create a line from here to here. Alright, and after that I go ahead and trim this area, and I press escape, and then I go ahead, select all these lines and click on define section. So here my section is defined. I can provide a name to it like a new section and assign a material property to it, and then simply click on apply. So this is how easily an irregular shape section property can be defined in MIDAS nGen. And we can see that over here. So if you would like to use this, then you can go back, simply say a beam you want to create. Alright, here we have our command at the bottom. So we can select this new section that we have just defined, and for now in sample, click on 2 points. Okay, so as you can see over here, our irregular shaped beam has been automatically, like very easily defined over here. Alright, let's get back to definition of section properties. And here I'm going to be like using section template for my RC beams, columns, and steel beams and columns. So here I'll use solid rectangle, and we have a beam of 225 mm by 450 mm. I insert the template, and further I can simply provide a name, beam 225 by 450, assign a material which is C30, and I can click on apply. Alright. So we have B225 by 450 defined. Next, we can also even just say insert template, and we can edit over here the height like 300 and enter. So modification also becomes very easy, and then further I'll just change the name over here to 300 and click on apply, and then further for my plinth beams, and apply. Next, for the steel sections, we can select code. We can select British Standard Code. There are many codes available over here to select from. So let's say I'm using BS, and here I'll select 100 by 75 for my top rafter. of my truss, and insert the template and provide a name to it like router. Okay, material is steel, and then I can apply. Then next one is for the struts. So for that I'm using a smaller section property. It's also going to be 50-50 by 4.47. So insert the template, and if you would like, we can make changes in the thicknesses and so on from here itself. And just name over here as struts. And apply and close. I'm not going to be creating many section properties over here, just few section properties that would become an example. So another box section that I have taken over here, I'll make a bigger section property for the box, mostly 50 by 50, and insert a template. Alright, so this is done. I can call it as a steel column and click on apply, and we are done with the section definitions. Next, we'll go back to our model. Now, the section definitions that we just did was for the beams, but what about the columns? Well, just for the columns, we need to go to the story, and from the story, we can simply use column member, and we can trace the columns. Firstly, selecting the correct material, we can just simply drag around the entire area where we have got our columns, and the program is going to automatically detect the column layer, and all we need to do simply is click on apply. So that is it. Just simply select and click on apply, and all the columns with different section properties will automatically get generated. Similarly, when it comes to foundation, like the isolated footings over here, we can simply select the thickness, select the sketch. It is going to detect all the lines that are enclosing each other. So it has detected all these lines, and then I click on apply. And as soon as this happens, the program has successfully generated the footings. A huge time is saved over here, and the next thing now you need to do is simply go to the next story and then create the beams. So again over here, instead of clicking on 2 points to create a beam, we can trace the beam. So we can simply use our PB section property, and we can use by select line segments and simply drag around the entire area and click on apply. Okay, pardon me, I think I've used incorrect plinth tracing file. Let me import it again. Yeah, plinth beam grid it was. Okay, so you can go back and forth at any point of time, no problem. All right, I'll do the same thing for the top. Okay, so here we go. We're on the plinth beam level, and then members, beam, and everything is already selected from the previous command. So simply select and click on apply. So here we go. We have got all our plinth beams. Same thing. We can now go ahead to the 3D and structure, and we'll change the file for the CAD drawing and take foundation 1 just to detect the column layer. It's not necessary that we need to have separate CAD files for the columns, for the foundations, for the plinth beams. It's not that. This was just for convenience sake. So here I have the column to be traced again. Height is automatically being detected because we have defined the story levels. And apply. So we are done over here with our columns, we're done with foundation, we're done with our beams. Next, let's go ahead to the roof level. And on the roof level as well, by just going to the beam, I'm again tracing all the beams. And here I'm going to be using a different section property. So that is going to be my 250 by 450. 225 by 450, this one, and then I click on apply. So this is one way of creating. We can also draw the beams by clicking on 2 points. Of course, conventional methods are also available. So you can simply click on 2 points and create the beams. So it's that easy, no need to worry. You can use your conventional methods as well. Alright, so this is done. Next, let's see how we can create slabs. So for the slabs, we have got slab member. And in this, again, we have different thicknesses that can be defined and used. So for slab, I'm going to be using 150. And here we have, again, analysis type, as in the type of slab that should be used for the analysis purpose. So we have 2 types, slab membrane that can take only in-plane stiffness. And there is slab plate out in that will have both in-plane as well as out-of-plane stiffness. So I'm going to be using this membrane type, the most conventional method. And further, we can simply go to the top view and we can select the periphery beams to create the slabs. So it's that easy. Just I'm dragging the mouse and I'm creating the slab. So those slabs will be generated in between all these selected beams. So I can even press shift and unselect few beams, whichever I do not want. So selection, unselection is also very easy. After this, we can simply click on apply. Okay, so you can see over here there is 2-way type of slab that has been generated, and some slabs are not having any markings on them. Well, those slabs are those which are not exactly rectangular. There's some change. Those will also be analyzed and designed. However, they will be not the conventional ones. They will be meshed. All right, and further, if you want to change the distribution, like instead of having 2-way, you would like to change it to 1-way, simply select and then change from the properties tree menu, the load distribution type. So it's not just one selection. You can do the selection, many selections at once, and then you can change the 2-way to 1-way type. And that's it. So we are done over here with our RC structure. Now let's go ahead and see how we can create steel, or what we can do for the steel. Well, in case of steel, we can have different methods, like we can directly start creating the members and using bodies, or we can use an importing function. So we already have our truss center line in AutoCAD, so I can simply import that shape or truss. Right, this is a 3D type, and this one is having a scale factor of 1. All right, so as you can see over here, a preview of the steel truss, and all I need to do now is click on OK. So here we have our sketch. It's not member. We have to still use or convert this sketch into members. So for that, we can go to the body. Now this body function in MIDAS nGen is a very interesting feature. It's so useful that you can convert these sketches into members. You can also create openings in slabs using the body tool. For example, if you'd like to create an opening in this slab, simply go to the plane. You can draw a circle. There are many options here, so I'll draw a simple circle. So a circle is drawn on the slab, and to create an opening, I simply go to the member, click on opening, select that circle, and click on apply. And it's done. We have got our circular opening easily generated in MIDAS nGen. Alright, now let's use this body tool again to convert into members. We can go to the left view very easily. No need to go to this box again. And now by using easy selection tools, we are going to be selecting few bodies or curves and convert them into members. So I'm selecting all these. Polyline tool so that I can easily select all the sketches, all the bodies, and then use the brace type, which is a truss type. I can also change it to beam or tension only or compression only type of element, and use the property which I want for the struts or braces and click on apply. So here we go. We have got our struts and brace members. Next, for the beams, the top rafter. So top and bottom rafter. So I'm going to be selecting easily using the polygon select. Alright, so whichever I do not want to select, I can simply press shift from my keyboard. Alright, and do the unselection. In this way. So it makes it really easy for us to do the unselection by simply pressing shift, no need to look here and there, and so on. So these are different functions that we can simply use. Alright, so let me use pick selection. Okay, there are actually plinth beams as well created in this model. You can choose to keep the plinth beams if you would like to get the analysis results, like really accurate ones. Alright, so selection has been completed. All I have to do is click on apply. So this is done. We can also take a look in 3D if we have used all the bodies correctly. So it seems fine. Alright, lastly, the columns. So I'll select column over here and select over here steel column as a property. Select and apply. Same thing over here. Simply select and I'll click on OK. Alright. So we are done over here with our entire model. It's a model, a complete RC and steel model in MIDAS nGen. All right. Now let's go ahead to the loading. How to apply loads in MIDAS nGen. It's very easy. All we have to do is simply go start with the self-weight. If you would like to apply self-weight, which is a usual thing. So self-weight is applied. Then further, we can apply point loads, beam loads, pressure loads onto our structure. There is arbitrary load as well. Okay, now this is all about the convenience that we can get out of MIDAS nGen. So here, let's say I have an area where I want to apply a load which is like little different from the others. So an example over here is that I go ahead, create a face draw a face basically. Okay, draw a face. It's kind of a triangular face. Okay, it's trapezoidal after I created. Okay, so we have got our face over here, and on this face we can go ahead to the loads and apply an arbitrary pressure loading on it. So we can select this face and we can apply the pressure. So this is in kilonewton per meter square. Let's say I want an additional pressure of -2 kilonewton per meter square. Well, that would be just 2 because we have our direction type as normal, and then click on OK. So here we go. We have got the pressure applied to our face. All right. So this is not getting displayed. Selecting the surface, yep, and that will be -2 for now, and OK. So we are done over here with application of a patch load or a pressure load, area load, patch area loading using the arbitrary load function. Next, we can apply loads on the slab using slab load type. Slab load type as in you can have all your dead loads, live loads, finishes, everything included in one go. So all you need to do here is define the load set like a live load set. Add and use it over here. Static load set 1 is the dead load set by default. Okay, and after that I can simply provide over here how much load I would like to provide. Let's say floor finish of -1 and a live load of -2.5. It's just an arbitrary information. So I click on add over here. So we have one load type, and we can have such kind of load types for different areas. And once we are done defining the load types, we can go ahead with the slab load assignment. We can select the slab load type and then select simply the slabs on which that particular load type is to be assigned. Okay, and this is a function of including only the slabs or 2D members. So I can simply go ahead and make a box around to select everything and click on OK. So here we go. We are done applying the slab load on the slabs that we have modeled. Okay, this is one normal method. Now the second method, that is, instead of creating any slab, how can we apply the floor loading? Okay, so we have that option as well, which was available in our analytical solution, that was MIDAS Gen. That is floor loads. So you can use that floor load command as well. Similarly, you can define the floor load type and assign the floor loads using the periphery beams. Okay, other than that, we have advantages of applying fireproofing load, snow loads, crane loads as well for industrial structures. Okay, so that's about the gravity type of loading. Now we'll go ahead to the lateral loads. In the lateral loading, there is wind load and static seismic as well as dynamic seismic response spectrum loading available. And these are all auto-calculated. So what we need to do is simply go to the wind load, assign wind load function. Okay, let's firstly go to the 3D. Okay, so we have our entire structure in our workspace, and I'll go again to the assign wind load option, and here we have different options available, like we can have an enclosed area type of wind load definition, open area wind load definition. In case of silos, we can have an equipment type of wind load definition, or the most conventional one, that is the story type of wind load calculation. So we can select right now, for an example, the story. And we have the option to automatically generate different load cases by defining only once. So that's there. Then let's go ahead to the direction and width. Well, we can apply the major angle like at 0, that means which will be in the x direction, and there will be 90 for the y direction. And further, there are eccentricity options, like how much do you want to apply the eccentricity, if it's positive or negative, or if you do not want to apply the eccentricity, which is none. And this eccentricity is, you can see it right over here. It is 15% as per the standard. Okay, most of the standards have 15% itself. So the wind load eccentricity is right over here, which you can modify. And we can see over here how the loads are going to get applied, basically at the center, or at a at what location is the center, and we can see over here the calculated eccentricities for the major and orthogonal direction. All right, this information can also be modified. Okay, so we will be having no eccentricity as such for our model, and we will go ahead with the wind load definition. Now, wind load definition is available as per different standards in MIDAS engine, like we have American Standard, IBC, European code. There is BS 6399 also available. So you can select Eurocode since that's what you're going to be using. Then further over here, we can see the average roof height, which has been automatically detected by the program as per the story definition. And further, there is basic wind speed, which can be modified. And right now I'm keeping all the information as the default ones. All right, further we can include the orographic effects, neighboring high-rise structure effects, and if there is raising of displacement with height, and structural factors. So the structural factor also can be modified with the help of this calculator that is inbuilt in MIDAS engine. So you can simply provide over here the frequency, like for example, it's 5 Hertz. So I'll click on OK, and you can, sorry, not OK, make it 2 Hertz, OK, and calculate. And see, you can see over here that the structural factor will be automatically calculated. All right, so I'm keeping the structural factor as 1 for now, and I click on OK. All right, and this is done. Definition is done, which can be used. We can have more such kind of definitions and then choose which wind load shall be applied. So here we go. We can click on Show Profile, and we can see how the wind load is being applied on the structure. This is the elevation and the pressures that have been calculated by the program. This is how you can simply verify, and you can also export this information to Excel sheet. And if there are any additional wind loads you wish to apply on the structure, that can be applied from here. All right, so we are done with the definition. Now all we need to do is click on OK, and just need not worry about applying again in the other direction. So it's done at once. Next, we will go ahead to the static seismic load. Again, over here, we can go ahead and provide the eccentricities, major or orthogonal, and that would be 5% by default. Eccentricities, I'm keeping none again. And then there is dynamic seismic loading that will be defined from the design function. Here again we have got the American as well as the IBC, UBC standard is also there, and EN, that is Eurocode, is available. Alright, here we have recommended as well as Malaysian National Annex. And then further we'll go ahead to the ground type. Okay, keeping all the default parameters, we'll go ahead and look over here at the bottom. There is approximate period. This is as per the code itself. So you can click on this three-dotted box and see over here how the period calculator will open up, just like we saw in wind loads. Here you can see the different formulae that are readily available for the program to calculate. So simply select the correct formula which is going to be used for your structure and get the period calculated automatically. So there is a lot of automation involved in MIDAS nGen, and you can also generate a report of how this seismic load has been calculated in a Word file format. All the formulae are there for you to check, and then you can simply go ahead and click on OK, close this, use it. You can say show profile to see how this is going to be applied. You can see the base shear, and you can add any additional loading. Alright, you can also click on generate load set for ortho, and for ortho you can give 1 like that and click on OK. So we have got now the loading in both the directions. Okay, so this is done. Now we can also go ahead and perform dynamic seismic analysis, that is response spectrum, by firstly defining the function and then the load cases. However, I will not be going through it because we have a little less time. There's so much more in MIDAS nGen to show. Okay, so moving ahead, we can also apply the earth pressure. So when it comes to water tanks, you can also apply the water pressure using this function. All you need to do is simply provide the density of the material that is enclosed in the water tank. When it comes to Eurocode, we have imperfection load as well that can be utilized, automatically calculated by the program. And that's pretty much it. Now we will go ahead to the boundary, which is the next step towards the right side. Alright, so when it comes to boundary, we have like really good options available. When like supports, the normal supports that you apply, those are available. However, we are having our footing right over here in our model. No need for a separate footing software solution, right? So we have our footings, and for these footings, we can actually have a soil structure interaction done. And that's by using the spring supports. So for footings, isolated ones, or there is raft footing, you can go ahead and provide a soil support. All you need to do is click on this property, click on add, and over here you can have user-defined vertical spring constants and horizontal spring constants, or you can also use the bolus method, which can automatically calculate the spring stiffness values. And here we have the option of linear elastic and compression only as well. So I'm going to be using compression only. And further over here, we can simply provide the information of SVC, like soil stress, allowable soil stress, which is, for example, 150 kilonewton per meter square. Okay, once I provide over here 150 kilonewton per meter square, you can see how the program is going to automatically calculate the spring stiffness, a vertical one and the horizontal one. And the damping ratio is 5% for the dynamic analysis. However, let's stick to the static one. Alright, so this is done. Automatic calculation of soil springs is completed. All I need to do is simply select all the foundations or footings. So these are selected and click on OK. And we are done. You are done. using or applying the soil structure interaction to our structure. Applying soil structure interaction actually makes your structure economical and more accurate. It's not just limited to raft foundations, but we also have pile support, which can be automatically calculated. No need to even draw the piles. Just have to define and assign it to your nodes or members. So that's the thing. Nodes of the members. All right. And next is there are point springs, also area springs as well. All these different types of springs, stiffnesses that can be applied on our structure so that we can have an accuracy in the model. All right. Other than that, when it comes to boundary conditions, there are links and diaphragms. Yes, there is diaphragm as well. So in the diaphragm, we can select how many degrees of freedom we would like to actually restrain. And then we can simply select the objects which we want to include in the diaphragm. Like, for example, I'm going to the left side. Okay, go to the front side, basically, and I'll select these members over here. It'll be easier if we go in the plane. Okay, and the diaphragm, selecting these. So as you can see over here, whichever members I've selected, the diaphragms have connected the nodes of those members. All right, this is one way, and then I can click on OK. So we have got our rigid diaphragm assigned to all these members. All right, and then further there is loads to masses for seismic analysis. So you can have 100% of the dead load, and for the wind load, I can have 25% to 50%, which will be assigned to all these types of loadings. Okay, so mass has been converted for seismic load analysis. This is also very easy for us now. We can now go ahead simply. There are offsets as well, which can also be auto-generated. So if you just hover over the mouse, you can see how the distances due to section offsets and rigid zones through members information such as shape offset can be assigned easily by one click. So I can say auto-generate, all members is already taken, and click on OK. So auto generation of offsets is done by just one click. Next, we will go ahead to the analysis tab. Analysis. MIDAS nGen actually has a really good feature over here in case of analysis. A very good advantage we have over here. And that one is about defining different analysis cases and running them simultaneously. By different analysis cases, I mean that you can actually make a group of the members, the loads onto which you want to apply and using which you want to perform the analysis, and the boundary conditions, different boundary conditions for different analysis cases. It's like you can do a lot of research on one single model in a very short period of time, so that you can get the most accurate and most economical structural analysis performed. So it's all about time, it's all about convenience, and all of this is provided to you by nGen. Okay, so in the analysis tab, we have different control parameters. So it's not a complete black box, but you can actually look into everything that it is doing internally. Like the mesh, we don't need to worry about the mesh, but still if you would like to have the mesh under your control, then you can take a look over here. This is the 2D mesh. By default, it is going to be 1 meter length. You can have a smart size by the program. Okay, so what smart size means is that it will have a smaller mesh size wherever there are changes in the directions. Like, for example, there are corners. At those corners, there will be smaller mesh size. And in other locations, the mesh size is going to be coarser. So that's the smart size method. All right, and further we can also have seed, as in we can define seeds at different locations, and you can control the mesh in that case. We can control what kind of element type should be used for the meshing. You can choose triangular, quadrilateral, or triangular plus quadrilateral, which gives more refined results. Okay, and all these things that you can definitely take a look at, and also we can go to the solver and you can see add number of processors into it or reduce or whatever you would like to do. Then further there is enable GPU acceleration. Well, this is also one thing that we claim, that MIDAS has got the most fastest solver speed, and the reason for that is because you can have number of processors as well as a GPU accelerator to increase the speed of analysis. Okay, so I'm just going to keep the default. Even though we do not use GPU acceleration, we'll see how fast the analysis is. So that's about the analysis settings. Next, we can create load combinations before analysis as well as after analysis. So here, since we're going to be performing analysis and design at the same time, I'm going to be creating load combinations over here. So load combinations can be applied to the entire structure as well as to separate members. I'm going to be having load combination for the entire structure at once. Again, we have option for steel members and RC members. So for steel members, we have EN3, and I can click on auto generation over here. We have automatic load combinations. You can see over here, and you can also actually choose which load combinations you want to select. So you can also use envelopes and click on add. So here we have steel fundamental envelope, which includes all the load combinations available over here. Then there is seismic, separate seismic load combination, and seismic envelope. Then there is characteristic, so for serviceability purpose, and frequent type of load combination, quasi-permanent type of serviceability load combination, as well as fatigue. So all these types of load combinations are available for us to make use of, and further the same thing we will do it for RC members. So using EN02 we can 92 we can go ahead and create load combinations automatically. So load combinations are completed, which can be used for design as well. Next, we can have our own mesh size control, which can be used by changing the analysis settings. And now let's go ahead and see how we can have different analysis cases defined for a single model. No need to create multiple models, just one single model, and you're done. So there is analysis for design. You can give any name to your analysis case. All right. And further, you can choose to only have the analysis done for the superstructure or only for the substructure. And then further, you can see over here the boundaries and masses that you can make use of, and here are all the loads. So you can even uncheck the loads that you would not want to apply on the structure. So in this way, and then you can create one analysis case by clicking on apply. Then I can create another analysis case in which I would like to have another set of loads applied onto the structure. And then click on OK. So that these are the two analysis cases which you can see in the analysis tree menu right at the bottom. And we can modify them by just simply right clicking and saying modify. Alright, further you can also perform modal analysis. So here we have analysis control, modal analysis control, wherein you can have the program find out the number of mode shapes which would satisfy the target percentage of mass participation. Well, we perform the eigenvalue analysis basically to find out the period and the frequency of the structure. So for that purpose, you can definitely go ahead with the modal analysis. All right. And that is it. You can simply click on OK and your modal analysis has been defined. Other than that, we can also perform linear buckling analysis for steel columns. We can have crane analysis done separately on the crane loads that have been applied. Then when it comes to a flat slab or slab, you can have cracked section analysis performed for the secondary effects. And yeah, that is pretty much it. Next, you can even choose the analysis, which analysis you would like to run. However, before performing the analysis, we will simply go ahead to the Design tab and define the design parameters. And after that, we can run the analysis as well as design at the same time. So let's do that. Pardon me. All right, so we are here at the Design tab, and we can perform the design by defining different settings over here. So let me take you through the design settings in MIDAS nGen. Well, there are certain design, general design settings, like which code you would like to use for steel as well as for RC. We have British standards, so you can use British standard as well. All right, but we will see the Eurocodes in this session. Okay, and the sway type over here is braced. You can change it to unbraced as well, and accordingly the program can automatically calculate the effective length factors. All right, then let's go ahead to the steel, wherein the design will be based on the partial factors mentioned over here. And then we have got auto calculation of the effective length factors, which we can again modify from here. And then there is unbraced length automatically calculated, then equivalent moment correction factors. Then further we can choose to check for torsional strength. It's not considered over here, but we can consider it, no problem. All right, and then further the strength checks, what reduction factor should be used, and the serviceability checks, and the fatigue check as well. That's about the steel. When it comes to RC, you can again have the same information over here. And also for RC, we have rebar definitions. Now, this is a very good advantage in MIDAS nGen, and that is you can get the arrangement of the reinforcement done ready-made for you by the program. So it's like you can define what materials you want to use, and you can even see over here which type of diameter you want to use, and for the diameter which material property you want to use. This is all available for you to select from and get the most accurate or most required results, design results from MIDAS nGen. All right, so right now it's batch setting, as in the same type of setting is assigned to the entire structure. We have main reinforcement grade as class A, and there is shear rebar grade for class A as well. We can modify this to BS, and we can select from here S460 and shear rebar grade as S250. All right, so that's about the material standard, and then the rebar arrangement, which can also be controlled. Like the cover thickness, we can choose clear cover, which will be provided right over here. By default, it's 0.4. We can change it to 0.02, 20 mm. And all these informations can be modified, like what should be the default diameter for the shear reinforcement, and if you would like to consider the splicing or not, and the default diameter of the main rebar. So that's about the columns, beams. Similarly, we can have for the columns, for the braces, we can go for the plates, walls. All the rebar information can be modified as per our requirement. You can also choose to have alternate rebars for slabs and foundations. So these are different analysis design settings, design settings over here. And I'll click on OK so that these settings will be utilized. Combinations are already there. We can even choose which combinations we want to use for our design purpose. And next comes the design group. Yes, we can create our own design groups, and with the help of these design groups, we are going to be getting the drawings automatically generated by the program. So you can click on design group over here, And we can go for the dialog box wherein this is about the steel members. So we can firstly make group names. So there is a group name that can be created over here, like steel beam. Okay, we can select all the beams, and let's say there are 2 types of steel beams, and we click on add. And we can put them under different sets as well. Those sets can be defined from here, like steel beam set. All right, and then we can choose those sets from here. The program is very easy to use and very intuitive. Need not worry like, oh, how to do and how to do this, how to do that, and so on. It's all given right in front of you. So that's one thing. You're done with one beam group. Similarly, we can create a column group. So that's a steel column. And group settings, I can say SC over here. And I can add 2 types of steel columns. So that's done. Oh, I should have selected over here the SC. All right, so that's there. Okay, then further, I'll go ahead to the RC now, and in case of RC, again, there is columns, so I'll just call them as RC column over here, and make a group name of RC, and select that group, and add the type, RC1, RC2, like that, and then further, I'll provide over here for the beam. Okay, selecting the beam from here, and calling it as beam, and selecting the beam set. I can make a B over here and get the suffix, suffix as 1 and 2, and click on add. So in this way I can define the design group names. Okay, close this, and then I can select from here the different group names, like for the steel beam, and let's say we are going to the left view, and we select over here. These are some beams I would like to select, and then this can be applied. So we can see over here the name given, steel beam. All right, then further, when it comes to columns, I'm selecting all these columns right over here. Okay, 10 objects are selected, and I'm selecting the group name as SC, and then I can click on apply. So SC1 is also done, and similarly I'll go ahead with the RC now. So RC column, I can select these RC columns and the group name and click on apply. Well, we need to have the same section properties, so we need to select basically the same sections, the columns having same section properties to define the group. So for that purpose, I'm going to be assigning for the column by selecting one column. That will be easy. Yeah, RC over here, selecting the RC column and the group name and apply. So we have over here a group which can also be applied over here. So we have 2 same section properties, columns having same section properties. So we have been successfully applying same group, design group name to these 2 columns. All right. And so on, we can go ahead and create different design groups and assign. And according to these design groups, the program can generate drawings automatically. So that's done. Next is the member parameters, as in we can actually assign separate parameters to different members. So that's about the member parameters. Everything is completely under our control. For example, the deflection parameters can be modified for a particular column or beam, steel column or beam. All right, so that's done about the member parameters. Next is check position. You can actually ask the program to perform the check at locations that you would like it to do. And then further, we can also define our own reinforcement and ask the program to perform the check. That's one thing. Now let's go ahead and define a design case. All right, design case as in just like there are different analysis cases, we can have different design cases. Design cases would be like we can select the analysis case and then we can perform the design case for that. And in that design case as well, we can choose which loads we want to use and what we would like to use in case of groupings that we have already done in our model. So that's the thing, and we can also do the selection of few members and then perform the design as well. So that's about the design cases that we can create. So everything is like on like what you would like to do in a very short period of time, instead of waiting for the entire design to be completed or waiting for the entire analysis to be completed. You can create different analysis and design cases and perform the analysis and design in a very quick way. So that's done. One design case has been created. I would also like to have a design group for the slab so that we can see how that can be done. So in slabs as well, for the RC slab, and there is foundation as well that can be designed in MIDAS nGen. So I'm just having one, and for the foundation, one design group. All right, and that's done, defined, and all I have to do is now simply select the slab, and then I can select the group name and assign. Similarly, when it comes to foundation, you can select one foundation from here and select the group name and click on OK. So here we go. We are done with grouping in a very quick way. Next thing, in the design case, I need to modify the design case as well. So when it comes to design, there is one design case that has been defined, and this design case can be modified, in which I like to check again if anything has been unselected. Okay, so the new cases, the new design groups that had been created are also included over here, so we need not worry. Okay, but it's always better to check. And always we can go ahead and run the analysis for the analysis cases that we have, as well as the design cases. We can choose which analysis that we would like it to perform. For example, do not want to perform the second and the modal analysis, and just one single design case. Further, we can check on rebar auto arrangement, and here we can have the program do the optimization of the rebars. So that one can be done by using these options, like it can do optimization by changing the section depths, columns, minimum section size for braces, then for walls, minimum thickness. So it can actually modify the depths and the thicknesses and do the optimization so that you do not waste your energy in finding out what is the right section property by modifying the model again and again. So this is like a one-time process. So here we have all these options. So here we can see that there is optimization not only for steel. There are many programs who have got steel optimization. However, in MIDAS nGen, we have RC optimization as well. All right, so that's done. Next, we can simply go ahead now and click on OK. Firstly, the program will ask to save the file. So I'll save the file right now. Okay, so here we go. We have got a message saying that there are members for which the analysis type would be required to change. And those were the ones which were having openings into them, because conventional slabs will not be having openings, or they will not be of any other shape other than the rectangle. So those are going to have different analysis types. And so we change it by clicking on yes. Alright, so here we go. The MIDAS solver has started. We can see how many number of nodes are there, how many number of elements are there, and what type of analysis is being going on. And this MIDAS solver is right over here. However, we can also see at the message window in the bottom how the analysis is being performed. So it seems there are some warnings over here, some similarity errors over here because of the incorrect modeling that could have been done. However, all those things can be checked by the program. So let's go ahead now. I'll go to the second one. Okay, wherein we have got the analysis and the design results. So there is analysis results right over here. Okay, for the analysis results, we can go ahead and use the analysis results tree menu. And with the help of these tree menus, you can check the results like the deformation. So this is the deformation of the structure. And the deformed shape has been checked on. You can check it off as well. So this is how the structure is going to get deformed. This is for the design 1 load case, however, analysis case. However, you can also modify it and check the result. For any analysis cases that you have run the entire model for. And when it comes to reactions, again, you can select which reactions you would like to take a look at over here. And we have a legend at the right side. So we can see over here how the program has efficiently provided us the information. It has given information like there is 0.3% of reactions which are having the value of 53.1, and maximum is 43.5%, which is having 4.42 kilonewton as the reaction value. So that's how we can get the reactions, and then we can also see the applied forces. And we can also even convert our reactions into loads by using create load by results. That also option is available. Then there are different results for the trusses. So we have the truss results right over here. And further for the beams, we can get the actual forces, the shear force values, the torsional moments, bending moment in the y direction, Z direction, and so on. So you can see over here how nicely the program has provided us with all the diagrams in the entire structure. You can choose to see all the values from here, but that will be like, showing a lot of values on our screen. So you can check that. Alright, and then further we can even see the plate forces. So here we go. There are plates on our structure, in our structure. I'll initialize so that we can get the results. So the analysis has been performed for these plates. Alright, there is eigenvalue analysis table as well. So we can see over here the period of the structure. And we can see the effective mass. and the percentage of modal effective mass right over here. So after 65 modes, the program has reached to more than 90% of mass participation for the X, Y, and rotation at Z about Z axis. So this is one file that I had created before, and this one had included automatic calculation or automatic number of mode shapes. Alright, so this is done, and further we can also see the deformation for each mode. That means we can see the mode shapes. So this is the mode shape 1, and further there are all the mode shapes, 65th mode shape, and so on. So we get the information, the analysis result information from the tree menu. We can also get the results in the form of tables. So for that we have a separate table tree menu. So with this table tree menu we can get the rebar information like the rebars in beams. We can select the beam, and for that beam we can, okay, there was no load combination over here. Let me go ahead. Okay, MIDAS engine seems to be running again now. Right, we can open up our model again. Okay, so here we go. We are done with the analysis results that we can check. And we were going to go ahead and look at the tables. So at the tables we can see the rebars in beams. So let's see all of them. Okay, seems like the design was not performed. Let me perform the design of this structure again because of the crashing. So we'll run the design. Right, after performing the design, we can look at the strength check result. Okay, and here we can see the status of our entire structure. Like, it's a lot colorful, but the reason for this colorfulness is because of different ratios, that means demand capacity ratios that have been achieved. There are many that have that require check. That means the ratio is very low. We need to do more optimization of those members. Then okay, that means the blue colors that we have seen, that we can see here, they are passing in a really good ratio, with a good ratio. Then for the critical, critical is basically, we can understand that it is very much closer to failure. So we need to be careful. Not good, which are the elements, members which are failing, and there is failure as well, which are completely failing again, and there are few members which are not checked if they are gray in color. Now gray all are designed. Now let us look at the different results like the combined ratios, actual ratios, and all these demand capacity ratios directly with the help of colors on our model. There is serviceability check as well performed. Most of them seems to be okay. There are just 2 columns which are not okay. Maybe we need to increase the size of those columns. Then further, we can see the results, different results over here. There is short-term deflection ratios that can be seen for the beams. Then the reinforcement applied, that is required reinforcement. So all this information that is applied, that is given by the program to us very much readily. The combined ratio for the steel. And if you'd like to take a look at what is the equivalent uniform moment factor that is given by the program. Sorry for the technical issues over here. Anyway, we have seen over here. I'll show again about how we can get all the design results on the software, on the model itself. So we firstly saw with the status of the strength, that means which members are passing, failing with the help of colors. And further, the same thing can be checked when it comes to serviceability. So this is like a contour form which we can use and get the result very quickly. And further, we have tables. So rebar in beam, select that beam, and for that beam we can see what is the reinforcement arrangement. So if it's like pink or red, it's not good, it's failing. And further we can see the rebar in column. So we can look at the column information. The braces, if there are any plates, walls, slabs. Walls can also be designed. Currently we have not created walls, however, we can have walls analyzed as well as designed in one structure itself, in the same structure, in the same model. And slab, so I'll just initialize and we can get the result for the slab as well. So by allowing a little bit higher diameters of bars, we can get the design okay or passed in the structure. So it's about what we provide to the program and then how the program will react. So of course, garbage in, garbage out. So we need to be careful in what we are providing to the program. All right, so that's about the table results. Now, the next type of result that we can get is with the help of the design results. Yeah, design report that can be generated by the program. Design report is in two forms. One is summary, one is in detail. So in the detail type format, we can get the member design report done by group, or we can do it by summary, by member. So by member, as in I need to simply select the members for which I want to get the design result. So I've selected one slab, and further we can go ahead and even take a look at the detailed result. So as we can see over here, the program is creating a detailed design report in a Word file format for the slab design. And as you can see over here, how the program is given the information of what formulae it has used and all the checks that has been performed and what requires to be checked. So there are many formulae that you can take a look at and then be satisfied with how the program is performing the design. So that's about the design report generated by the program. MIDAS nGen can also have information regarding the story tables, like the story drift, in which the program will check and tell us if about the remark, if that drift, if the drift of that level is going beyond the limit or not. We can also manage or modify the check. We can change its code. And here we have drift on the center of mass, which will be compared with 0.0015. We can also modify it to 0.02 and click on OK. So now it will be comparing with the allowable story drift ratio of 0.2. So that's about the story drift. Also, we can get the story shear force for response spectrum loading, story mode shape, eccentricity information. And the program is also capable of providing us a torsional amplification factor. You can check with the torsional irregularities in the structure and also stiffness irregularities like the soft story check and the weak story check. So that's about the design, for the story tables. Then in case of design, we can also even double click to get the total design result table. So you can click on this column and you can see if, like all in all, if it's passing or failing. So there are many good methods in which you can actually check the entire structural analysis and design. All you need to do is understand what all features which would be useful for you, and then you can simply go ahead with the same practice for all your projects. Alright, so here we have another option, that is a steel section modification as well as RC section modification, and then this will be updated by the program automatically by performing the analysis and design again. So in this way we can have optimization performed for steel as well as RC structures. Next, let us go ahead now into the report and drawing generated by the program. So here we have generate report option available, wherein we can open up a new file for our structure. Alright. And this is like a report maker of MIDAS engineering software solution. All you need to do is just provide the information that you would like to keep on this report. So a cover, then table of contents, then further you can have the project information, what design code standards you're using, and then further the list of steel columns, and you can have steel beams and so on. All this information is there. And you can see the analysis modeling, and then further we can also see what is the lateral load data that has been applied on the structure, if there is any temperature or displacement load applied, and then further what boundary conditions, like we have used the point springs or area springs, or what support we have applied on the structure, and then further the different member properties, the analysis results like the beam forces. With this, the program is going to give us the image of the beam forces, so we can also select which beam forces we want to include. So from here we can actually select the type of analysis from here, and what should be the content of this result. If you would like to see only the axial or only the bending in Y, you can just choose the bending in Y and just shear in Z, like that. right? And what all the results you would like to check for. So the envelopes results will be shown right over here. So these are like different results that you can provide in your report. Also, when it comes to design, you can put up the total design result right over here. And then further about the percentage modal effective mass, that can show that you have 90% of mass participation successfully achieved in your structure. So these are different, this is like item list, which you can modify from the report property over here. And then you can simply go ahead and say generate all. By clicking on generate all, the program will check the latest information from your model and then create the entire report. So this actually helps us when we have different modifications, and we can see right now the entire report has been generated with what we have provided over here. This is the wind function information, equation of wind loads, and this is the analysis results that we can see. All right. And then further, this report that has been created, we can save it in the form of Word file. There is export report to Word file, so that can be used and edited as well. And also we can open the same file and do the modification using the report maker itself. So it's not a complicated type of a report maker, but it's a simple one because it has got the item list which can be saved as well and reopened for your future projects. Alright, and once you make any changes in the model, you can simply click on generate all and get the updated report in your in front of you in a very short period of time. Alright, so let's get back to MIDAS nGen, and we are done with our report generation. Let's also see how we can generate the drawings in using MIDAS nGen. Well, here you need to take care that you have groups created, and with the help of these groups, the program is going to be able to create the drawings. So the program is capable of creating structural plans, as well as it is able to create the table format of your design results. And also there are detailed diagrams that can be done by the program. So we can just go ahead, look at the settings. There is column layout. We have just one column over here that had been assigned with the design group. Then there are framing plans. So we can see from here which are these framing plans which the program is going to be generating. Then the rebar arrangements, again over here, the rebar arrangements for different plans will be shown on the plan in the plan view. Alright, so we are selecting all the member sets. We can also choose to select either the superstructure or substructure. And once we're done with this, we can simply click on OK. And after that, we will go ahead and click on Generate Drawing. By clicking on Generate Drawing, another software solution, which is nothing but a part of MIDAS nGen, that is MIDAS Drawing, will open up. MIDAS Drawing is similar to AutoCAD 2D. We are having MIDAS Drawing that has been opened up in front of us right now. And we can see that this workspace is very much similar to AutoCAD 2D. You can use all the functions that are there. Now the drawings that are to be generated are right over here. We can go for the settings of the structural drawings as well. The structural drawings settings will be required to do just once. And once you are done with all these settings, like checking out what should be the dimension, size, font size, and what should be the rebar arrangement information, how do you want it, and further if you would like to overlap the same rebar arrangement, and what should be the marking done on the drawing that you're generating. Basically, everything that a draftsman starts from scratch is automatically done by the program over here. So you can see all the hatch patterns and detailing stuff. So after you're done with the settings for the drawing, then you can go ahead for structural plans. So you can choose which structural plan you want to see. And once you are, rebar arrangement plan is not completed. So once you are done, we can simply click on confirm, and the program is now going to be generating all these drawings slowly. Like it will be creating 20 number of drawing sets over here as required by you. And all you need to do is now just wait and look, or wait and watch. Once these drawings are generated, you can do the modifications of any type, like additions of any sections, different types of sections, or any typical drawings that you would like to add into it. You can do that over here itself. So right now the structural plans are being generated. So by looking at these two bars that are going blue right now in front of us, you can actually understand how fast the generation is being and why it's taking so much time. Basically, it is processing the cross beams between other members, and it is checking for the different types of beams, and accordingly it will be showing with different colors and with different line weights, with different symbols as well. All those settings that you had done by yourself, they are being done by the program on the drawing. So as you can see that we have created the entire model using a drawing, and then we have come up with an output which is again in the form of drawing. So that's how efficiently you can get the result. So here we go, we have got a column layout. The column sizes and the foundation sizes, everything is there. And you can see the column list as well, very much readily available for you to make use of. And also you can generate the framing sections as well. And you can also go ahead and generate the bill of materials. So here we can click on generate bill of materials, which can give us for the RC members, steel members as well. Steel members, again, we have option if you want it center to center or we want to deduct the overlappings. And let me uncheck center to center, just looking at the overlaps. We can see, or we can get right now the output generated for in the Excel sheet format. So here we have the Excel sheet, which is getting generated by the program. So it will be having all the information of the RC structure that we had in our model, as well as the steel structure. So bill of materials for our file is generated. So a type 2 type of steel member, or rather the information is given, like the section and what is the material used, the length, the quantity, total length, and we can also get what is the painting surface area, that is the outer surface. Then let's look at the bill of material for RC members. So for each section, how much is the unit length, the quantity for the type, like beam, for column, for slab separately. And you can get the concrete volume in meter cube. We get the rebars in tonnage, and we can get even the formwork area. So this is how efficiently we can get the results. This is for foundation in the Excel sheet format, which you can readily use. So let me go back to the presentation. All right. So we have seen the demonstration of MIDAS nGen, how we created the entire steel and RC model in MIDAS nGen using the drawings, and then we saw how we could generate the drawings, the output drawings that is required. So in this way, we have integrated the CAD as well as CAE into our structure, into our procedure, and we have done the automation by using the automation and optimization of optimization processes. We have performed the modeling and report generations in a very short period of time of the entire structure. When it comes to automation, MIDAS nGen has strengths like we saw. By simply selecting the layers, the columns were automatically generated with the different sizes automatically created, defined by the program, and similarly for walls it can be done. Then we saw how the lines, or these lines, can be converted into beams. We can also draw the beams conventionally by snapping onto the halves of the members. So this is just a quick overview of how the modeling procedure was easily done. Then by selecting the peripheries, we can create the slabs, and whichever locations where we don't want the slabs, we can delete those. And in this way, we created the entire floor plan. Again, over here, there are some fast CAD-based modeling functions available, like moving, copying, and we can also do the extension, the extend command, and trim command. This can be used for any cases. Over here, we also saw how openings can be generated in a slab. Then, how easily you can create a shell structure. This is an example. How we can even trim the inside portion. We can go through them and do the meshing. The program will do the meshing by itself, and we can get the analysis results. We can even reduce the mesh further. So no need to worry about the mesh size. You can increase or decrease the mesh size as you require. Then we also saw how wind loads can be automatically defined and assigned to the entire structure, be it a building, an enclosed structure, or open structure, or we have got an equipment like silos. Then further, seismic load also is automatically defined and assigned. Then there is auto generation of mesh. There is smart mesh that is done by the program. You need not worry about the mesh size or also the meshing of the shells or plates or slabs that you have modeled. Now, when it comes to optimization, that time we can see how the analytical model is optimized by simply using offsets, and we can also generate structural drawings. Alright, then by using different analysis type of elements, we can have an accurate modeling done, and accordingly we can generate the drawings as well. Then we can perform steel as well as RC design on our structure. We have Eurocode as well as British Standard. As you can see, it's highlighted in blue and orange. There is optimal RC design as well and steel design as well. And further, coming to the high quality of report generation by the program, like we can get the detailed report in this format, wherein each and every formulae of the code utilized will be given in a Word file format. So this report that is generated is as per the code. There will be subclass numbers also provided to you, and you can actually see how the program has performed the entire design. And this is not just a general design information. This is about each and every individual member. And then we have the integrated structural report, that is the report maker, which can easily create the entire report as you wish, as you would like to have. And this template can be saved, and you can also use this template to create your project reports again and again in just one click. Then drawings also can be automatically generated. So we have seen the column layout, column and foundation layout. Similarly, we can get the results for all the floor levels. This is just a quick go through about how the structural calculation reports can be generated by the report maker in MIDAS nGen. Alright, now looking at the MIDAS support service, we have technical materials available online for you to understand how to use MIDAS nGen software solution. All you need to do is download the software solution, get the protection key ID from us, and use these videos for starting your projects. You can create your project in a very short period of time and check the results by yourself. Also, our technical support team manages with training programs. If you need to have a training session on MIDAS nGen, you can definitely contact us. Let us know, and we can have another online webinar session wherein we can invite you and your engineers for the trainings online. So need not worry of a new type of software solution. We are there to support you all throughout your time of learning, as well as if there is any project that you would like us to help you with, as in terms of the software, then as well we are there. So let us now conclude our introduction session, our introductory webinar session on MIDAS nGen. MIDAS nGen is an integrated solution, that is CAED solution. Whatever you see is you analyze and design. There is automation, a lot of automation involved in MIDAS nGen that can help you perform the model or create the model in a very short period of time with a lot of accuracy. Then there is optimization, wherein the economy of your structure will be taken care of by the program. And further, we have high quality reports and drawings generated automatically by the software solution. So here we have the benefit wherein we can perform fast design so that we can win the bids. Design quality would be based on practice, and there will be on-time design ultimately done by the construction team, but that's again another issue. So whatever you can do from your side to make the process quick and get more projects, MIDAS nGen could be the solution for you. Yes, and of course, in in case of construction, we can also perform revisions and quickly let them understand if there are any modification in the structure. So no need to worry about any modification of the structure as well. I'd like to thank you very much for attending the webinar session.